Hey everybody, and let's take a look at section 3.6, graphing with calculus and calculators. I actually was going to skip this video, but then I decided I would just go through and show a couple points because it's pretty explanatory when you read through it. Basically, the concept here is that you would use your graphing calculator to graph your function and then use the calculus that you know to verify or to debunk what you see in your calculator. Now, a couple things before we start. The calculator window of your graphing calculator, if you use a TI-83, up in the very top under the screen, you'll see a button that says window. That's where you will change your window settings. And that's super important for examining the graph. You can see here, figure 1, this is a graph that was graphed from -5 to 5 and from -1,000 to 41,000. So that same graph over here in a different window looks much different. You can see that you have the graph actually going below the x-axis. Looks like it comes up and then continues increasing. I want to show you though, I'm going to try to move this over a little more because this graph here and this graph here are the same function. This graph is from -1 to 1, -1 to 1, zoomed in on this tiny little section right here. Okay, so you can see how important it is to take a look at that because we've got increasing to decreasing going on here and then back to increasing. It's going below the x-axis again in a point where we didn't realize it was going to go below the x-axis. It looks like it is at the x-axis here. So using that information for your graphing or for the graph is very important. Now you can take the first derivative and the second derivative of the function. This is a function that's a polynomial, 2 to the 6, so fairly easy for us to differentiate. And we can see that if I take the first derivative, I have to the 5th power, and that comes out looking almost like a cubic graph because it is to the 5th power. This is your first derivative graph. So this tells us that my values are negative until I get to about -1.6, and then my values are positive. And if I take a look over here at this graph where we are zoomed in a little bit more, I can see it looks like I have a critical point around 1.6, and that's what that would mean if my values went from decreasing to increasing. I would have a critical point. So these negative values here on the slope graph are your decreasing values, and then here are your increasing values. Now, the other interesting thing is it also shows that it does go below the axes right here in this one spot. If you look closely at it, I can't zoom in when I'm recording on this device, but if you take a look closely at this on page 245, you can see that as well. Then the second derivative is the concavity. So concavity, you can see here's the second derivative. These are positive values until you get to 1.2. What does that mean in a second derivative? Positive values mean concave up. Then negative values mean concave down. So if I'm looking at this, I see that it is in fact concave up until I get to this point about over here where it switches from concave up to concave down. That's about 1.2-ish, and that's about 1.2-ish in the same place. Okay, so that's how you can use your graphs in your graphing calculator to check your main graph. Now, the other thing that I want to emphasize here, again, window is super important. So here I have a window that goes up to 3 times 10 to the 18th, and then from -5 to 5. Well, this graph looks, you know, it just looks kind of crazy, like something I would see, in a hospital on one of the monitors. Now, if I change those values a good bit and make them from the standard -10 to 10, -10 to 10, then I can see that there's a much different picture. Okay, so now you can probably hear the fire siren in the background. I live fairly close to a firehouse. All right, so let's take a look at this same example that we're looking at here. I want to point out that we're dividing by x squared. So dividing by x squared would mean that we would have here some kind of possible asymptote. Maybe. Or a critical point. Maybe. So we know something's going on here. The other thing that I can do is that I look at it as limit approaches -infinity and positive infinity and check for horizontal asymptotes. And I do see that, in fact, when I divide everything by x squared, and if you remember the little trick I taught you, since they're both x squared, you see that we have a y equals 1 horizontal asymptote in this problem. Now again, you might want to zoom in to certain parts. I want to see what exactly happens in this area here from 0 to about -3. Okay, so here we have that area blown up so that we can see. And then you can use the trace button on the calculator where it says trace and use your arrows to go back and forth, and it will give you the values, the x and y values on that graph. Okay, example 3. I want to point out here too, we have some things going on where it looks like I have a 0 at -1, and also it looks like I have something going on at 2 and at 4. Now if I use my standard calculator settings of -10, 10, -10, 10, this is what I give. It's not very helpful at all. Okay, so if I take a look at the same graph though in different settings, here it shows that I have my asymptotes at 2 and at 4. So it depends on when you're zooming in, zooming out, you can see it shows a lot of different attributes of this function. The other thing be careful about too is under your settings for your calculator, you will have either connected or dotted. When you are graphing with your calculator, you want to make sure that it's dotted. Otherwise, it'll connect every point and it won't show you your asymptotes. Okay, so that's another thing to be careful about. Again, example 4, here's a sine function. And over here we have a graph of this from 0 to pi, from -1.1 to 1.1. We can take a look at the first derivative of that function, and that can help me determine where some possible critical points are. And I can see that it is positive values from here to here. So that means it'll be increasing from 0 to about 0.6, and then from about 1 to 1.6, and 2.1 to 2.5. Okay, so and then the decreasing intervals that's when I have these negative values. So that tells me I'm going to have some decreasing intervals here from 0.6 to 1, because here's negative values. And then from 1.6 to 2.1, negative values. And then over here, it looks as if I have from 2.5 to pi, also decreasing values. So that's how you can use your graph of your function and your graph of your derivative on the same graph to kind of take a look and evaluate and get your intervals of increasing and decreasing. And using your trace functions will help you determine where exactly that will go from increasing then to decreasing. Okay, I think that's about all I wanted to go over with this section 3.6. I think the rest of it is pretty explanatory. You can play around with your calculator and graph a little by hand to look at intervals, increasing, decreasing, and inflection points just for practice, and that'll be some big help. So I will talk with you soon and see you in section 3.7.